Welcome to Spring LIB.
In this problem, we're given some data for a simple pendulum on Earth. We're told that it has a period of 1.6 seconds. And we're asked, what would that period of the pendulum be on Mars, where the value of gravity is different than it is on Earth? And so for this problem, we just need to use the relationship between period and gravitational acceleration. And it's an inverse relationship. So what we'll do is we'll just find the equation, using the equation for period equals length, square root of length divided by gravitational acceleration. We'll solve for the length of the pendulum, and the length will remain unchanged on Earth and Mars. And then from there, we'll find the period of the pendulum on Mars. And so data that we're given, so we'll use G on Earth, and we'll go to 3 significant figures, since that's what they gave us for Mars. And we're told the value of gravitational acceleration on Mars is 3.71 meters per second squared, and the period of our pendulum on Earth is 1.60 seconds. And so our equation for period of a simple pendulum, t equals to 2 pi times square root L over G. And so L is the length of our pendulum. And so we'll just solve that for L. And so from there we'll get square root L over G equal to T over 2 pi, and square both sides, and we'll get L over G equals to T squared over 4 pi squared. And then solving for L, we get L equals to T squared G over 4 pi squared. And so putting in our values, we get L equals to, so we've got a length, or a t, period t on Earth is 1.6 squared, and our g on Earth 9.81, and divided by 4 pi squared. And that gives us length of our pendulum 0.636 meters. And so that will be the same on Earth and on Mars. And so our period on Mars, Tm, is going to be equal to 2 pi times square root L over value of gravitational acceleration on Mars. So we've got a 2 pi times square root 0.636 over 3.71. And if we work that out, we get a 2.602. And so we'll take that to 3 significant figures, since that's the data that we were given, was 3 significant figures. Okay, so our answer will be the period of our pendulum on Mars is 2.60 seconds. And we can just check if that makes sense. So the value of G goes down from Earth to Mars, goes down from 9.8 to 3.7. And the value of T, period, goes up from Earth to Mars. And that makes sense since T and G have an inverse relationship in our equation. And so everything makes sense there.